Good morning, everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 24 is on the screen, and once again, number 1 is to simplify, and to lowest terms, and it says to factor each of the numbers. Part 1A reads 40 over 72. Part B reads 21x squared over 7x to the fourth minus 28x cubed. Numbers 2 and 3, it says factor, and 2 reads, let me make a change on that one. Give me a second. Number 2 reads, x squared, let me read that again. X squared, trying to make it a minus, my goodness. X squared minus 5x minus 24. Number 3, x cubed plus 3x squared minus x minus 3. For number 4, it says solve for y and evaluate when the domain is -1, 0, and 5. And the equation given is -9x minus 3y equals 12. And number 5, it reads add or subtract, and they give us 2 25ths plus 3 20ths. Alright, I'll give you guys some time for that. Copy and go. It shouldn't take you more than what? 3 minutes, yeah? 4 minutes? What do you think, Brooke? 7 minutes? Alright, 5. Copy and go. Alright, let's see, just for the sake of time, what did you get for number 1? Number 1, Andrew. 5 nines? Yes? Okay. And of course, to get there, you should have gotten 8 times 5 and 8 times 9. Right, the GCF, because now we can factor out a 1, and that leaves us with 5 nines. Okay. Number 1B. Let's see. How about Mr. Q? All right. 21 becomes 3 times 7 times x times x. What's the GCF for these two? 7. What else? X to the third, and that leaves us with x minus 4. Now, since I have the x's factored out over here, I'm going to factor these out as well. X times x times x. Like that, I'm going to use this. And it's easier to see the giant ones. You guys see the giant ones? Right here is 1. How about another? Yeah. How about another? Yeah. So what does that leave us in the numerator? 3. How about in the denominator? X times x minus 4. There you go. Number 2. Andrew, pass someone. Raymond, what'd you get for number 2? X minus 8, x plus 3. Hands if you got that. That is correct. Let's go. Yeah, once again, 1 times -24 should be -24. And then the -5 down here. What two numbers multiply give me -24 when you got to give us -5, -8, and +3? Yes? Okay. Number 3. Group x squared. We're left with x plus 3. GCF here is what? -1. We're left with x plus 3. So my factors, x plus 3. And what's left? X squared minus 1. However, am I done here? X squared minus 1. No, Mr. Q, that's a difference of squares. X plus 1, x minus 1. Then I bring down the x plus 3. Remember last night's home plate? This? Yeah? Okay, good. Alright. Equation, solve for y. What'd you get for that one, Pamela?
Y
3x minus 4. Negative 3x minus 4. Hands, have you got that? Okay, good. So my domain, which is all x values, is -1, 0, and 5. So, what did you get for the range? The range. Pass someone, Pamela? Range. Go.
I got -1.
-1.
-4.
-4.
And -19.
-19. Hands, have you got that? That is correct. Let's go. And number 5. Pass someone. Go.
Andy.
Andy, what did you get for number 5?
Didn't do that.
Okay. Help him out. Noor, what did you get? What? Guys. All right, let me help you guys out. We got 2 and 3, like Michael Jordan. Okay. So what is GCF between 25 and 20? 5. Both of them should have a 5, so this is 5 times 5. This is 5 times 4, which means this one needs another 5, yes? And this one needs a what? A 4. A 4. Therefore, so 4 times 2 is 8. 5 times 5 is 25 times 4, that's 100. 3 times 5 is 15 over 100. Focus on the numerator. Aww. 23, Michael Jordan. Let's go. Hands if you got that. Yeah. All right. Set it aside and let's copy the agenda for today. Agenda. We got warm-up number 24. We just finished. Today we're moving on, guys. Let's go. Quadratic equations. Yeah. Let's go. Kind of like, I don't know if you've gone to the beach and then it looks really like mellow, and then you go into the water, and then you turn your back to get a selfie, and then all of a sudden here comes a wave, and bam! Straight up like that today. It's going to come like a big old wave. Bless you. But we got this. Home plate 6 problems only. Only 6 problems. Only. And for those of you that are watching online, here's your Nearpod code. So like that, in case you don't copy the whole thing, you can get the home plate from the screen on Nearpod. SIV8Y. SIV8Y. So the home plate should be in there as well. Alright, so last night's home plate were 6 problems for you to make up and factor. 3 difference of squares and 3 cubics, but that's for you to practice. I'm not picking those up. You're like, oh man, Mr. Q, I wanted that credit so bad. Yeah, I know. I get you. This is tonight's home plate, only 6, and it reads, for numbers 1 and 2, solve each quadratic equation by graphing, square roots, and factoring. Number 1 reads x squared minus 25 equals y. Number 2 is y equals 3x squared minus 12. For numbers 3 and 4, the instructions are solve the quadratic equation using square roots. And then we got negative 4x squared plus 16 equals y. And for number 4 is negative 4x squared plus 64 equals y. For numbers 5 and 6, is to solve each quadratic equation by factoring. Number 5 reads x squared plus 7x plus 12 equals y. And number 6 is 2x squared plus 5x plus 2 equals y. I'll give you some time to copy that. Copy and go. Once again, our objective for today can solve and graph quadratic equations by graphing, using square roots, and factoring. And if you notice, we have a new concept today, yes? Yes, Mr. Q. So what's our concept for today? Christian. Very good. Quadratic equations, right? And that goes in the center of your FAIR model, yes? Quadratic equations. Now, some of you are going to start having flashbacks to your Algebra 1 years, yes? You're like, oh yeah, my favorite Algebra 1. Alright, quadratic equations, what are they? Quadratic equations are two variable equations where the highest degree is 2. And here is a quick intro, students. Two variable equations, students. Once again, what are quadratic equations? Two variable equations. However, the highest degree is 2. So let's see if we can picture it. Can you picture an equation with two different variables? Yes, okay. And do you know what I'm talking about in regards to highest degree of 2? Yes, now we've been talking about polynomials so much that now we know how to find degrees, right? So highest degree of 2, that means that one of the variables has to have a what? A 2, or a squared as a power. Examples, copy these. X squared plus 3x plus 2 equals y. X squared minus 9 equals y. And y equals 3x squared minus 11x plus 6. All of those are examples of quadratic equations. So let's see, according to the definition, there are two variable equations. Let's see. Do I have an equation? Yes. Two variables. Yes, yes, and yes. Highest degree of 2. Let's find out. This degree is 2. This one 1. This one 0. This one 1. But the highest degree is 2. Same thing with this one. Same thing with this one. So now that we know what they look like, let's look at the non-examples. What are not quadratic equations? Look at those before you copy. Tell your neighbor why those three are not quadratic equations. Why are those not quadratic equations? Alright, interesting conversations, and I saw Valerie all explaining it to her neighbor. So let's see. Valerie, why is this one right here not a quadratic equation? It doesn't have the exponent of 2. So what would be the exponent on this one? 1. That's the highest degree. If it's the highest degree of 1, this is known as a linear equation. Okay? How about these two? Why are these not quadratic equations, Lewis?
The first one, x to the power 2, because it's not an equation.
It's not an equation?
The second one, because it's an expression.
It's an expression. So both of these are expressions and no equal sign. Okay. Fairly straightforward, yeah? Alright, so you take a picture of this, send it in your social media, and you say quadratic equations are hashtag what? Brianna. What is it? Okay, I couldn't hear, sorry. You said always what? An exponent. Exponent of what? 2. Let's go. Okay, good way to start. Hashtag what, Juliana? What makes quadratic equations quadratic equations? Second degree, so exponent of 2. I'll write it. Second degree, okay. Hashtag equal sign, yes. And one more. Sandra. Not expressions, okay. We're missing one critical attribute. Look at it. Tell your neighbor what would be one thing that's missing there on our hashtags. Bam! 2 variables. That is correct. 2 variables. Alright. Now that we got this, any questions with quadratic equations? No? Y'all ready to get to work, yeah? Okay, go like this. Bear with me because it's going to go bam. Copy this, please. Example 1. Solve using square roots. X squared minus 9 equals y. Just copy it. Solve using square roots. X squared minus 9 equals y. All right? Writing utensils down, look up to the screen. Here he goes. You can copy afterwards. Here he goes. So they want us to solve using square roots. Step 1, after this is given, is this. So in words, what would you tell your neighbor step 1 is? Change y to what? 0. Okay. Step 2, check this out. Isolate the variable. That means I need to leave this by itself, and you're just paying attention. So if I use the inverse operations, what would I do? Add 9, x squared equals 9. You're just paying attention. I'll let you copy up here. And the last step, this is known as solving using square roots, because the last step is using square roots. Why? Because I need to cancel this squared. What is the inverse of canceling a square? Square root, square root. This cancels that. We're left with x equals, what is square root of 9? What other number is times itself equal to 9? Okay, here it goes again. The rule is, what number times itself gives us 9? 3 times 3. What other number times itself? -3. So this one would be +3 and -3. Copy that, please. These are my solutions. Zeros, roots, x-intercepts. And some of you that were with me in Algebra 1, here goes a flashback. Mr. Q, do we have to write all those every time? Yes, you do. Right? So as you're copying that down, here goes the process one more time. The first step was to change y to 0. Step 2, isolate the variable by using inverse operations. And step 3, or the last step, take the square root, because we need to cancel that square. And that's how we get plus minus 3. And how do we get plus minus 3? Well, one number times itself gives us 9. -3 times -3 is 9. And 3 times 3 is 9. So therefore I write plus minus 3. So many of the fingers I'll come figure out with these so far? Ah, 5, 5, 5, 5, 5, right? Do another one, yeah? Just to solidize this. Copy this one. It says solutions, zeros, roots, x-intercepts. X-intercepts. Now, check this out before I move on to the next one. They're solutions because we just solved the equation, yes? Okay, that's obvious. Why are they zeros? Tell your neighbor why they're zeros. Yeah, because we substitute 0 for y, and then you're going to see a little bit more clarifying that when we graph. Why are they roots? Come on now. Yeah, because we take the square root. And lastly, this part you're going to see when we get to the graphing portion. Let's go. Our favorite. Copy this. Example 1Q. X squared minus 64 equals y. See if you can do this one all the way by yourself. Copy that and go. I'll give you 35 seconds, yeah? All right, go. All right, check with the neighbors, see what they got. All right, let's see. You should have changed this to 0. You got x squared minus 64. From there, we isolate the variable. That means leave this by itself by using inverse operations. We end up with x squared equals 64. And last but not least, what is this process called? Solving by square root. So square root, x equals plus minus 8. Hands if you got that. That is correct. These are my solutions, roots, zeros, and x-intercepts. X-intercept. So now that we have the process, let's do another one. Let's crank it up a little bit, yeah? Copy this. Example 1 megacube. And it reads 3x squared minus 27 equals y. I am confident you can do this on your own. Now, listen to the words of Obi-Wan Kenobi as he told it to Luke Skywalker. Use the Force. So, use the process that you learn all the way through. You'll see how you come up with a solution at the end. Okay? Copy and go. Answer, please. Yes? -3 plus 3, yes? Alright, so let's see. Let's go through the process to make sure we got it. Step 1, set it equal to 0. 3x squared minus 27, and I said trust your steps, so what do? Isolate the variable, so we add 27, we end up with 3x squared equals 27, but Mr. Hugh is still not by itself, so what do we do with that 3? Divide by 3, divide by 3, leaves us with 1, x squared equals 9, and last but not least, square root, x equals plus minus 3. Hands if you got that. Let's go. Solutions, x-intercepts, roots, zeros. Yes? Alright? Shall we? Copy this one. Example 1 super Q, 4x squared minus 100 equals y. How about 20 seconds on this one, yeah? Copy that and go. See what you got for that one. We good, yeah? Let's see, what'd you get for this one, Audrina? X equals what? Plus minus 5. Hands if you got that. That is correct. Once again, the whole process, I'm not going to use colors this time, so set it equal to 0, 4x squared minus 100, then add 100 to each side. From there, 4x squared equals 100, divide by 4. So that leaves us with x squared equals 25, and at the end, square root, and that's how we get there. Okay? Copy this one. Example 1 super duper cube. And let's do this one together, since it has a little slider at the end. You're going to see what I'm talking about. Okay, help me with this one, please. Raymond, go. Change y to 0, so we got 2x squared minus 16. Continue, Andy. Add 16, thank you. Continue, Andrew. We got 2x squared equals 16. Divide by 2. We end up with x squared equals 8. Philip, continue. Square root. X equals plus minus. You're like, wait a minute. I can't think of a number that gives me square root of 8, Mr. Q. Then just leave it as is, square root of 8. You're like, oh, I get it. Yeah, I'm going to show you how to find the decimal equivalent of those radicals. But for right now, for the purpose of just following the process, just leave it as is. Everybody with me? All right. So these are my what? Solutions, roots, zeros, x-intercepts. Yes? Copy this one. Example 1, Michael Jordan Q, -5 x squared plus 9 equals 0. And what do you guys notice on this one? They already did the first step, yeah? Okay? All right. All right, let's see. Help me with this one, Juliana. Go. Subtract 9 to both sides. Thank you. We end up with -5x squared equals -9. Pamela, what do I do next? Divide by -5. Divide by -5. We end up with x squared equals negative divided by negative is a positive, and I leave it as a fraction. Okay. Next step, Lewis. square root, this cancels that, x equals. Question, can we take the square root of 9? Yes, plus minus what? 3. Can we take the square root of 5? No, so we just leave it as square root of 5. These are my solutions, zeros, roots, x-intercepts. Alright, so up to right there. Show me your parents how come you are with these. 5 fours, yeah. The only ones that are going to give you... And he's all like, 1, yeah, right. Oh. Anyways, the only ones that are going to give you a little bit of a curveball is these that end up with a radical. Does that make sense? That you can't simplify? This one and this one. But like I said, eventually I'm going to show you how to simplify these and these, because we can't have a radical on the denominator of a fraction. We're going to do that next step later on. Okay? Alright, now that we're done with those, let's move on to factoring. Copy this one. Example number 2. X squared minus 9 equals y. X squared minus 9 equals y. Just copy it, and let me walk you through the process one more time. Once again, it says solve by factoring. No more square roots, and now we're going to focus on factoring. Okay. So here we go. Step 1. Step 1, it has to be equal to y, and it has to be in standard form. Equal to y and in standard form. Let's see. Equal to y, is this in standard form? Yes. Step 2. I'm going to substitute 0 for y. That's always the case. However, in that same step, I'm going to check to see if there's what? GCF. Is there a GCF here? No, so I bring this down. Copy that really quick. Once again, step 1, it needs to be equal to y and in standard form. It was. Okay. Step 2, substitute 0 and then check for GCF. If not, then just bring it down. Alright, so now here goes the next part, factoring. Look up to the screen. Since this is not a trinomial, it's a binomial, it's a difference, and it's a square. According to your home play last night, you should know how to factor this just by looking at it. Say never the factors of x squared minus 9. Alright, I think Lenny's got it. Go. X minus 3 and x plus 3. Lenny in the house, let's go. Who remembers that one? Yeah, these are difference of squares, and we still set it equal to 0. Copy that, please. Now, the next step, I'm just going to elaborate on the side. Don't copy this, just follow along. Check this out. What is 2 times 0? What is 0 times 3? What is x times 0? 0. What is 0 times y? So now check this out. What if I said x times y is also 0? What could x be? Or what could y be?
0.
Either one could be 0, right? So that means this times this is 0, so this could be 0, this could be 0. With that same idea, look at this. This times this is 0. So what does that mean? That this could be 0, is that correct? That's why I write x minus 3 equal to 0. Or this could be 0, that's why I write x plus 3 equal to 0. Copy that, please. Just wanted to elaborate with that numbers so that you can see it. Yeah. And look at it. Doesn't that just want you to solve them? Right? Solve them. Yeah. So what do? Plus 3 plus 3, x equals 3. How about this one? Minus 3 minus 3, x equals negative 3. And these are my solutions. Zeros, roots, x-intercepts. Let me walk through the process and make sure we got it. Step 1, make sure it's in standard form and equal to y. Step 2, change it to 0 and make sure there's no GCF. Step 3, factor. Here, since this was a difference of squares, we went straight to our factors. From there, set it equal to 0 and solve. Tell me if everyone shall come figure out with these? Yeah, should be familiar, hopefully. Do another one. Copy this one. Example 2 cubed. X squared minus 64 equals y. Alright, let's do this one together. So, is it equal to y? Is this in standard form over here? Yes. Continue from there, Rachel. What do I do there? Set it equal to 0, thank you. X squared minus 64, and is there a GCF? No. Next, I need to factor. So, what are my factors here, Brisa? X minus 8 and x plus 8. Hands, have you got that? Yeah. From there, continue. Miguel. X minus 8 equals 0. X plus 8 equals 0. Let's go. And Dana, finish it off. What do I do next? Solve. So what do I do? Add 8 to each side. So this is x equals 8. Minus 8 to each side. So x equals negative 8. And these are my solutions. Zeros, roots, and x-intercepts. Tell me if you're talking computer with these. Yeah, we got this. Yeah? Yeah. Oh yeah, you can do that. Yeah, so the question was, Mr. Q, can I just write S, Z, R, and X for simplifying the names of it? Fine. My goodness, I'm going to get an app. How about you guys get an app? And the names appear right there. Bam. They're like, now you're talking, Mr. Q. Copy this one. Example 2 super Q. I'm going to give you a head start on this one. See if you can follow the process. Make sure you follow all the steps. And then I'll come right after to catch up. To act like tomato. Ready and go. All right, read. Example 2 super Q. 2x squared minus 50 equals y. Copy and go. All right, let's see. Help me out, Valerie. What do I do first? Set it equal to 0. Okay. So, question to you guys: when we do set it equal to 0, what is that same step? What do we do on that same step? Check for GCF, which is what? What divides both? 2. Yeah, 2. That leaves us with what? X squared minus what? What's 50 divided by 2? 25. Okay. So far so good? Alright. How about this? Can we factor this inside of here? Yes. Tell your neighbor what x squared minus 25 is. In the meantime, I want to bring down the BFF. There it is. Okay, Pamela, what are they? X plus 5, x minus 5. Yeah, because this is 25, yeah? All right. Next step, Sky. X plus 5 equals 0. X minus 5 equals 0, but you forgot one. 2 equal to 0. They're like, Mr. Q, but that doesn't make sense. Well, at this time, we're going to eliminate that one because it's not true. But we still need to set it equal to 0 so we can do that step together. All right? So here, now we just solve. Minus 5 minus 5, x equals negative 5, plus 5 plus 5, x equals 5. These are my solutions. Let me write it completely. 0 root and x-intercepts. Show me your fingers. How come figure out with these now? Factoring. Yeah, 4, 5, 4, 5. Okay. So we got solving by square roots. We got solving by factoring. But these are simple factoring ones, right? Let's crank it up a notch. Tweezy. Look at this one. Look up. Don't copy this. We need to factor this. That means the 20 has to be over here, right, in order to start factoring. So what do? Subtract 20, subtract 20. We end up with 5x squared minus 20 equal to 0. And then GCF, and the rest is history, yes? All right. I wanted to get to this one. Copy this. Example 2, Michael Jordan, Q. X squared plus 5x plus 6 equals y. X squared plus 5x plus 6 equals y. Let's do this one together, yeah? All right, so is it in standard form? Yes. Is it equal to y? Yes. Continue, Andy. Set it equal to 0. X squared plus 5x plus 6. Okay. Now notice we're still factoring, right? We're not solving by square roots or anything like that. Has someone, Andy? Philip, since there's no GCF, how can we factor this?
You could do the powering.
Right, Ricardo? Yeah? So the invisible coefficient times 6, that goes up here. The middle term, 5, goes down here. So what factors of 6 add up to 5? What two numbers, when you multiply them, give us 6? When you add them, give us 5? Christian? What two numbers multiplied give us 6? 2 and 3. That is correct. 2 times 3. All right. So I rewrite this. Bring down x squared. Bring down the plus 6 equal to 0. But the middle term, this one, is going to become what? 2x and 3x. You're like, oh, I remember these. Of course. What do we do from there, Raymond? Group. Let's go. Raymond in the house. GCF here, guys. X, we're left with x plus 2. Plus GCF here. 3, we're left with x plus 2 equal to 0. So what are my factors? X plus 2. What's left over? X plus 3, all that equal to 0. And what is our last step? Lewis. Or our next step, my bad. X plus 2 equal to 0, x plus 3 equal to 0, and then we solve. Make sure you're copying that or it's coming right next to. X equals negative 2, minus 3 minus 3, x equals negative 3, and we know the names of these, yes? I'll leave that for Juliana to write down. So, show me your fingers up in the air with these. Yeah, okay. Now for your home plate, you have one of these, and you have one that looks like this. 2x squared plus 7x plus 12 equals y. Of course, first step, set it equal to 0. But then how do we factor this one? What goes on top? 24. What goes on the bottom? 7. You know what to do from there, right? All right. So, without further ado, your favorite, a blast from the past. Let's go! Solve by graphing. X squared x squared minus 9 equals y. Copy that, please. Now your coordinate plane, just do a y-axis, x-axis, and you don't have to put the tallies right now. Just do the x and the y. Okay? You're like, oh, I remember these, Mr. Q. Oh, yes. Alright. Y'all ready? Here we go. This is probably the easiest one of them all. You're like, yeah, right. Yes. Watch. First things first, let's make a table. Ready? Here we go.
Oh.
No, not that kind of table. Lewis was drawing a table, X and Y, and then put out the table. That was pretty good, right? Yeah? Yeah, that's pretty good. Alright, so check this out. For my X value, I'm going to substitute 0. And for my Y value, on the next row, I'm going to substitute 0 for Y. 0 for Y, twice. You're like, why twice? You'll see right now. Check this out. So I'm going to start with the value of X being 0. So if I substitute that in here, what is 0 squared? And what does that leave us with? Negative 9 equals to what? Y. So that goes right here. Okay, next. Now I need to substitute 0 for what? For Y. So that leaves us with X squared minus 9 equal to 0. Question, how do I solve this? We can either factor or square root, is that correct? Which method do you want to use? Square root? Well, do whatever method you want. I'm going to use square root. Plus 9, X squared equals 9. My last step, I do what? Square root, X equals plus minus 3. What does that mean, Mr. Q? That we have two answers, right? Positive 3 and negative 3. Okay. Alright, here goes the last part. Let's graph these points. This is 1 point. 0 of X, negative 9 of Y. 0 of X, negative 9 of Y is right there. So on your Y-axis, just go all the way to negative 9. Place that red point right there. Then we have two more. We have this one, positive 3 of X, 0 of Y. Positive 3 of X, 0 of Y. That's in blue. And then the second point, negative, or the third point, negative 3 of X and 0 of Y. Negative 3 of X, 0 of Y. 1, 2, 3. There it is. All right. So how do we graph this, Mr. Q? We go always, like mathematics, language arts, you go from left to right, connecting your dots, or your points. So just follow the point. After this one, which one comes next? This one and then that one. So then I go from left to right. Students, parabolas, parabola students. This should be familiar, right? So now check this out. We're solving by graphing. So I want you to circle this one and this one. And we just drew a dog. Pretty good, right? Pretty good, yeah? These are my solutions. Why? Because they are the x-intercepts. Also known as zeros. Also known as roots. Show me your fingers how to figure out with the graphing portion. 3, 4, 5, 5, 5, 4. Okay? So for tonight, you only have a couple of these of graphing. Use that table exactly how it is. The video will be uploaded. Have a good one, guys. See you guys tomorrow. Bring your parents tonight or send them, please. Bye.